can hypnosis change chemoreceptor sensitivity to carbon dioxide? Now that sounds like a fully loaded question, and it sounds a bit crazy. But in this episode of the Breath Science Podcast, we're going to break down a study from 1986 based off new models of breathing. That's right. In the last 3 years, there has been a shift in the scientific literature to suggest that breathing is more so related to behavior, memory, and learning than it is to metabolic activity. We dive into this really deeply in the Breath Science certification. However, for this case, we're actually going to look at a study that took 20 individuals. And what they did is they used hypnotic language to put them into a trance whilst they were wearing a mask that provided 15% carbon dioxide. Traditionally, what's thought is that carbon dioxide basically stimulates chemoreceptors and that causes us to drive to breathe. Now it does, but only to a certain extent. Within ventilation, which is our total breathing, we have a respiratory rate and we have our tidal volume, which is how deep we breathe. CO2 itself only really makes a change in how deep we breathe. Whereas the stress is more so to do with respiratory rate, non-metabolic inputs, arousal states, emotions, afferent signals from the muscles when we start to exercise, but also central command, which is related to perception. So in this study, what did they find? Well, they did 4 trials. The first trial was essentially just the individuals were sat awake with CO2. Then the second trial was sat awake with a suggestion just to breathe normally. Then they did this trial of breathing under hypnosis. And then they did the trial of breathing under hypnosis with a suggestion to stay relaxed. And we can see just up here the difference in the relationship between the CO2 tension, so the amount of CO2 in the body, and the ventilation, in that when there is a curve that is a little bit lower, means that ventilation response is reduced. This suggests, according to the paper in 1986, that there's something going on in the brain. But typically looking at this, a respiratory physiologist, exercise physiologist, or maybe even a respiratory scientist would look at go, that looks like someone's becoming more sensitive to carbon dioxide. But if we actually look at what goes on up here, when CO2 kind of is signaled to the brain that there's a change in pH, the thalamus tends to integrate information across to a part of our brain called the insula. And that insula is essentially detecting homeostatic threats based off interoceptive internal sensations, i.e. that's what air hunger is. In the middle of the part of this brain, we have the BNST, which is kind of nicknamed the secondary amygdala, and is predicting homeostatic threats to send information to our amygdala to create a fear response. And at the top, we have the cingulate, which is processing emotional information. Now, all 3 of this information is extracted and goes to our frontal lobe to be recorded as memory. Now, I believe that pH is actually the thing that when it changes, it presses record. And that information that then is transferred across into the brain through whatever happens in our conscious experience is then programmed into memory, and that shifts our breathing behavior. So what happens generally is that the information is sent across, there's a threat, that information is sent to the brain, to the amygdala, to create a negative affect, a negative feeling with high arousal. That's what air hunger creates. That is to create a behavior to change our breathing, to breathe faster, so we blow off more CO2 and bring pHs into a normal range. But air hunger is also a negative affect, so it's a behavior that will create usually more of a freeze behavior, which is to prevent you moving forward. So i.e. you might slow down with your exercise. Or if that's been conditioned during panic attacks to an external source, we might then create avoidance behaviors with that source. But what does hypnosis have to do with this? If we look at here, this is a meta-analysis or systematic review looking at the impact that hypnosis has on the brain. And hypnosis works on the insula and it works on the cingulate. So under hypnosis, what I believe is actually happening when we have a high level of CO2, the hypnotic suggestions to relax is changing the relationship that we have with the sensation. It's making us calmer. And therefore, the information that's being processed through those two parts of the brain is being recorded into the memory, but also less of it is being triggered through the amygdala. We are training the brain to have less noise. We're training the brain to respond differently. And therefore, the top-down control of our behavioral component of breathing reduces, i.e. respiratory rate. Now, there's plenty more evidence here to suggest, and there are probably another 7 studies that I've looked at that have compounded over a period of time, I would say over the last year now, that have allowed, based off this new model of breathing, to see how our air-hunger relationship is not down at the level of the chemoreceptor, but potentially more at the level of the brain. Some of those studies actually looked at exercise intensity. So a very similar study I'm going to pop up here was an older study that looked at using hypnosis during exercise. Now, these individuals were told that they were going to exercise at a low intensity, a moderate intensity, and a high intensity. Then they did a waking period in the moderate exercise intensity. I think it was maybe 15 minutes of cycling. They were then put into a hypnotic trance and told that when they were cycling that it was very light exercise. On the next session, they were put into hypnotic trance and told it was very moderate exercise. And then on the final session, it was looking at high intensity exercise. And we can see up here, I keep pointing to the wrong direction. We can see up here that actually during those individuals, when they were told that it was in high intensity exercise, ventilation increased massively. Meaning the individual's brain was tricked into believing that the intensity of exercise was much higher than it was, suggesting again that there's more of a thought-related component to our breathing, which fits with the model of Andrea Nicolai's breathing of non-metabolic inputs and metabolic inputs, and that behavior potentially is more of a factor when it comes to changing our breathing than CO2 itself. They are just a couple of studies looking back into studies in the 80s before we had this new information in the 2020, 21, 22. That's what I love about science, is we can look at old studies off new models and we can change and see the outcomes, and we can actually see whether people were on the correct lines. And it seems as though in both of these studies, the people who wrote these studies were indeed hinting to a fact that there's a top-down mechanism all those years ago. Can't believe this has not been noticed by many other people. And therefore, I'm making a suggestion that in breath coaching, we might need to change the word CO2 tolerance to air hunger tolerance. And that caused quite a lot of discussion on my social media. If you want to learn more about this and we want to learn how to actually then utilize this skill so that you or your clients can get better results, can relate to their sensations in their body better, can relate to the external environment better, then do check out www.breathscience.com.au. Drop any questions you have, email me. I know this one is quite profound information. I love it. I hope that you love it, and we'll catch you again next time.